Hi, my name is Aadesh and I'm a master's student at the University of Maryland. I'm presenting my project titled The Python Ecosystem is Messed Up and Here's Why. For this project, we scraped the entire PyPy.org and collected information from more than 200,000 packages. All this information was represented in form of a directed graph where a node denotes a package and the edge shows that a package X requires a package Y. This helped us create a massive dependency graph to run our queries. The first thing that we did was try to understand how the ecosystem worked. When you try to pip install a package, the system hits pypy.org and downloads the package for you. It then runs Python 3 setup.py install to install that package. So pip basically runs arbitrary code from the internet on your laptop. Similarly, it's known that importing a package executes it in Python. Thus, a malicious package can run arbitrary code on a user's system. So, being security researchers, we did exactly that and created a malicious package. Our package managed to get complete remote access of a victim's machine. We even managed to open the camera and get a click. This is extremely scary. We then came to our next question. Even if we created a malicious package, how would we spread it? Would users directly have to install a malicious package? Turns out that the users may install a genuine package which somehow imports a malicious package, or a package which through multiple hops imports this package. Every hop increases the attack vector. Our research shows that even if we consider just 3 hops, an average Python package trusts 14 other packages. This is a really large attack vector. But the main question is still unanswered. Why would someone import a malicious package in the first place? The answer is really simple: by mistake. Attackers have actually found ways to force these mistakes. Here are some ways through which these attackers typoscot names to force downloads. They release packages which sound the same, or simply change Python 2 to Python 3 to force a download. I know the pessimists, like we all security folks are, will ask, has the ecosystem been exploited? Of course it has. One such attack came to light just 2 months ago. A package named Jellyfish was caught stealing SSH keys. This package was live for a while, but had very few downloads. As we can see in the graph, the downloads suddenly boomed when the typo spotted another popular package and listed Jellyfish as a dependency. Then we started to think, how do we defend against these attacks? That's when we bumped into the Guardian project, which typoscots popular packages so that an attacker cannot typoscot them. So they're using methods used by an attacker as a defense. Packages created by the Guardians simply raise an error if a user tries to install them. The project is really interesting, and it also helps us get a lower bound on the number of mistakes users actually make. The Guardians can proudly say that they have saved more than 250,000 incorrect downloads. Our research also helps us identify other problems like open source violations. For example, a package released with an MIT license may have imported another package with a corporate license. So, where do we go from here? As we can see, the impact is really high as Python is becoming extremely popular. It is being used in critical businesses, and this has a huge chance of getting exploited. We've come up with some potential solutions to these problems. What's interesting is the transferability of these solutions, as they'll work for other package managers too, like npm for JavaScript or NuGet and Chocolatey for C++. Any questions? See you at the conference.